Okay, so we're going to put inverse trig behind us a little bit. We're going to focus on the next, 3 or 4 sections on something called trig identities. Now, fair warning, this is going to be a little bit abstract for some of you. A lot of you are going to really like these sections because they're kind of like little puzzles and you need to try to figure out what's going to happen. And then others, it's going to be a little bit tougher. So make sure, please ask questions and come in when you need to. Now, hopefully this box up top looks familiar. We looked at it just briefly in Chapter 6, but then we didn't do a whole lot with it. Well, now it's going to become your new best friend. We're going to use it for all of Chapter 7 and even into Chapter 8 a little bit. So what we'll do in class is I'll explain why each thing in this box works, but right now I want you to kind of take them as what we call identities. An identity is something that you know is true. Okay, so for instance, we've tried and true Pythagorean theorem, right? Now what I'm saying is, when you see something like, I'm just going to pick one, cosine squared plus sine squared, you're going to know that it equals 1. And then every time you see sine squared plus cosine squared, we're going to try to replace it with 1. All right, so again, identities are something that you're going to trust to be true, and in class I'll show you why they actually work. Now, what we're going to do in this whole section is we're going to try to prove that one side of an equation equals the other side. And we do that through these identities. We manipulate them, we change one thing into the other thing, and then we see that they hold true. Again, it's a little bit abstract, but hopefully after doing this for a few days, it'll make a lot more sense. Now, we have 5 ways to accomplish this. And I'm going to go in these slides one by one by one. So the very first one we're going to talk about is turning everything into sine and cosine. And this little trick actually works out more than you'd think. We're going to use it quite a bit in these sections, even when we combine it with the other tricks. All right? Okay, so I know it sounds a little bit strange, but let's just take a look. You guys keep the box right in front of you because I want to zoom in so I can write nice and big. All right, so the first trick, turn everything into sine and cosine, and we're trying to turn the left side of this thing, we're trying to turn sine cotan x into cosine x. Now, typically, we take the side that looks harder. So for me, the left side looks harder, and we try to turn it into the easier side. Okay? Now, look up at the box. If I want to turn everything into sine and cosine, well, this thing is already in sine. It's sine x. How would I turn cotan x into sines and cosines? So looking up at the box, hopefully you can see the third one over on the top says cotan is 1 over tan, and then the last one says cotan is cosine over sine. Well, if I'm trying to use the sine cosine trick, I'm going to turn cotan into cosine x over sine x. So I'm replacing it with something else. Okay, and then I drop down this sine x. All right, now we take a step back. Remember what we're trying to get it to be. We're trying to get it to be cosine x. So now, hopefully you can see the algebra move. I can cross those sine x's out, and all I'm left with is cosine x. So I accomplished what I want. Now you might be thinking, why are we doing this? Why would I want to prove that something equals the other? And the short answer is, when you get to calculus, wherever you take it here at St. Stephen's or in college, you're going to want to simplify things like sine cotan and turn them into nice pretty things like cosine. They're a lot easier to deal with if you can break them down and simplify them. Now look at this second one over. And again, it's under the same heading, turn everything into sine and cosine. I see secant sine on the left and tan on the right. Okay, so I'm going to work on the left side. It looks harder to me. And if I have to turn everything into sine and cosine, well, sine is already set, but secant, okay, so look at the box, or maybe you already can think about it. Secant and cosine are reciprocals, so I can replace secant with 1 over cosine. And then I have sine x over here. Okay, now, you might already be able to see it, but I'm going to put it together. I'm going to write this as sine x on the top, cosine x on the bottom. Okay, now peek up at the top there. See how sine over cosine is the same thing as tan? Well, now I can replace it with tan x. Now look, I got what I wanted. So that one's done. So the next little trick is multiplying numerator and denominator by an expression. Now, it can be a lot of different expressions, but typically, that expression is the conjugate. Okay, so now kind of just remember from algebra or wherever, if I said 1 plus root 2, and I said, what's its conjugate? You'd say 1 minus root 2. So a conjugate is simply changing the sign in between the two parts. So if I'm looking at number 3, and I see secant minus tan on the left and secant plus tan on the right, the conjugate idea should kind of spark in my head, because on the left I have a minus, on the right I have a plus, and I can see that those would be conjugates. So then I say, okay, maybe I'll take the right side and I'll multiply it by secant x minus tan x. So I'm multiplying top and bottom by secant x minus tan x. Okay, so this time I'm working on the right side, and I'm trying to get it to be the left side. So on the top I have secant x minus tan, because it's just times 1. On the bottom, I have secant squared x minus tan squared x. All right, now peek at the box above. In the box, the Pythagorean identities, I see something like this. I'm going to write it down here so it doesn't get in my way. I'm going to write 1 plus tan squared theta equals secant squared theta. So that's the numbers in the box up top. Now I need to somehow turn that into secant squared minus tan squared. Okay, so can you see what we're going to do here? We're going to actually subtract the tan squared over to the other side. Okay, so then I can see, I have a 1 left on the left side, and on the right, I have secant squared theta minus tan squared theta. Okay, so now look at our problem in red up here. That means that secant squared minus tan squared is the same as 1. Okay, so look what I have. I have 1 on the bottom, and then I have secant x minus tan x. That's exactly what I wanted. So that one is done. All right, here's another one where the conjugate idea kind of makes sense. Look at the left. I have 1 minus sine x on the bottom. On the right, I have 1 plus sine x on the top. So I'm going to go in and multiply the conjugate. I'm going to choose the right side just because I have more space to work. So I'm going to multiply by 1 minus sine x over 1 minus sine x. Okay, so now on the right, I have 1 minus sine squared x over cosine x times 1 minus sine x. Now, I'm not going to distribute the cosine on the bottom because look at what I have. I have a 1 minus sine x on the bottom, and that's what I want. See, I want a 1 minus sine x on the bottom, so I don't want to mess it up by distributing the cosine it. Okay, all right, so then my next step is I'm looking at the top and I see 1 minus sine squared. And then look at the box up top. I'm going to write it over here again. So the box up top says cosine squared theta plus sine squared theta equals 1. Okay, so if I subtract my sine squared over both sides, look what I have. I have cosine squared theta is 1 minus sine squared. Okay, so now back to my problem. The numerator says 1 minus sine squared. Well, now I can replace that with cosine squared. And on the bottom, rewrite what I have on the bottom. Cosine x times 1 minus sine x. Okay, now look at the algebra. What can happen now? I have a cosine x on the bottom and a cosine squared x on the top. I can actually cross them out just like I would any other algebra. And then I get cosine x on the top, 1 minus sine x on the bottom, and that's what I wanted. Okay, now that this video is just over 8 minutes, I'm going to go ahead and stop this one, and I'm going to reload another one and start with number 5 on the back.